Okay, so let's talk about advanced secure networking. And advanced secure networking really provides the most advanced level of security um, of these solutions, I would pose. And the reason for that is because it relies on entanglement. And entanglement is the key resource for advanced secure networks here. So what can we do with entanglement? Entanglement allows us to run a whole suite of quantum key distribution protocols. So beyond the prepare and measure BB84 style QKD protocols that I just mentioned, the next generation of QKD protocols rely on entanglement. And protocols like E91, BBM92, device-independent QKD, these all rely on entanglement. And why is entanglement so great for these? The core value add of entanglement here is that it eliminates the need for these trusted relay nodes. And so that's always good when you're thinking about a crypto system. You want to eliminate as much trust as possible in your network. You don't want to rely on trusting certain nodes or certain actors in your network to maintain security. Okay. The nice thing about entanglement is that it relies on this multi-use infrastructure. So an entanglement distribution network, this infrastructure that can support advanced secure networking, can also be used for other applications, which I'll get into in a second. So with entanglement, we can also enable other cryptographic use cases beyond just symmetric keys. So QKD is great for establishing symmetric cryptographic keys, but we can do other things with entanglement as well for security. So there's a whole family of protocols that are called QSDC, or Quantum Secure Direct Communication Protocols. And these protocols, using entangled photons, you can actually encode your sensitive data in the photons themselves. So instead of using the quantum signals to establish a key and then using that key to encrypt your traffic, in QSDC, we're actually encoding our sensitive data directly into the quantum signals. And that has some other notions of security, and there are pros and cons with the actual throughput you'll see at the end of the day. But QSDC is a whole other family of protocols beyond just symmetric keys. Entanglement also allows us to run protocols like quantum teleportation, which is sounds like magic, and it really kind of is, where with entanglement you can kind of view entanglement as a tunnel, right? And you can teleport a quantum state from point A to point Z through that entangled tunnel without ever actually sending that sensitive quantum state on the network itself. It sort of magically appears on the other side. And so that's a very interesting kind of use case, both for quantum applications, but also for security, once the throughputs really improve, that we can use teleportation to directly transmit very sensitive, kind of small data sizes. Okay, so I mentioned multi-use infrastructure with entanglement. So advanced secure networks really rely on entanglement distribution, but are also compatible with these other applications as well. So these networks can connect quantum computers together via entanglement. This can really scale up the quantum computing power exponentially with these interconnects. In these sort of entanglement distribution networks with quantum computers, we're also that also enable protocols like distributed quantum computing and blind quantum computing, where quantum computers themselves they're blind to the actual data and computation that are input. So there are use cases where you want to hide that sensitive data or that circuit or that quantum algorithm you're running from the quantum computing vendor over the cloud, right? So there are notions of security and secure networking to quantum computing cloud vendors as well. And so I mentioned advanced secure communications as sort of the killer app of entanglement and advanced secure networking. With eavesdropping protection, this mitigates the Q-day attacks that we mentioned before, and also supports these other applications. And finally, there's a whole other suite of applications known as quantum sensing and distributed quantum sensing here. So quantum sensors, things like atomic clocks, magnetometers, gravitometers. They have a lot of applications in the energy grid and in military for position, navigation, timing. So thinking about networks of these sensors connected via entanglement can really open up a whole suite of doors for future applications as well.